Hello, Assalamu alaikum. Can you hear me?
Assalamu alaikum, sir.
Alaikum salam. Okay, good. I think today it is 12:18 according to my clock. So up to 12:30, we have to wait. If anybody got any class or something like that, then come and join us. And until that, as I told you 15 minutes earlier, to come to discuss about the previous lecture. If you have any question regarding that topic, then we can discuss it now. And I'm asking you, do you have any type of question from the last lecture, as well as anything regarding the course or any other issues that can be discussed today? Okay, so are there anyone got any type of question? Please let me know then. Yes, hello. Anybody got any question? Hello, can you hear me? Do anybody? Oh. Hello. Okay, just a minute. Okay. Okay, can you hear me? Hello? Hello?
Yes, sir, we can hear you.
Okay, good. Thank you very much. At least someone should respond. All are dark, then how I understand, you already disconnected or you're not connected or something a bit active in that reason. So anybody got any questions regarding the course or the last lecture, what I have talked and I have uploaded, and there are some practice problem also. You can see some other sort of documentations uploaded. Do anyone of you have any question? If no, then you can be silent. Tell me that no, sir, we don't have any question. Then maybe I can talk about something else or whatever. But if you're silent, then I am silent. It's meaningless to come early. Yeah, Anika Bushra Shaha, do you have any question? Anika, you are in the top of the list.
Yes, I can hear you. Yes, sir. So I don't have any question.
You do have? No. I can't understand. You told me you do have question or not? Your microphone.
No, sir, I don't have any question.
Yeah, okay, good. No problem. Thank you very much. Anika Farjana, do you have anything to?
Assalamu alaikum, sir.
Alaikum salam, sir.
Sir, I don't have any question.
Yes, sir, please go ahead.
Sir, I don't have any question.
Oh, I'm sorry. You also don't have any question. Okay, that means all of you are silent, means nobody got any question. Something I can assume, right? Okay, good, no problem. Now, in that situation, what I'm thinking to tell you that we are going to have our first class test next week, Sunday. All of you note it down, and Uh, the syllabus will be whatever the thing I will teach you up to this week, end of this week. That means today's class and lecture 3, lecture 4. That means 1, 2, 3, 4. These 4 lectures will be the syllabus for City 1. If you note it down, that City 1 will be on, I'm noting down, you also noting down these things. On what will be the date coming then? What will be the date next Sunday? How come you all are
25th.
silent? You're dumb people.
25.
25th, 26th. Now tell me the correct one.
25.
25th.
25.
Ah, that's right. So all of you should be in the classroom, not outside. Your mind should be inside. Okay, is it 25th? First, when you join at sharp 12:30, I'm going to start the class test, remember. So you have to come before 12:30, and the class test rules and regulation, I uploaded on the BUX. You can check the class test rules and regulation, but still I'm just telling you the same thing what I have done in the fun test. In the fun test, or the way we have taken the class test, exactly the same way I'll be taking the class test. So the time will be 15 minutes and another 5 minutes will be processing time. Within 20 minutes, you have to do A to Z everything. If 1 minute late in submission, -1 mark. This is the way you have to think about. So -1 and a 2 minute, -2, like that way. After 5 minutes, you get -5 minutes. So be careful about it, because when you submit it, it will be recorded in the email at what time you submitted, remember. So everybody should be careful to submit it in time. Procedure is same. So still I'm going to send you again the class test procedure or any test, proctor test procedure in my subject. So I hope that you all got it, and the lecture will be uploaded, and already 2 lectures uploaded, and you can get it from there, that at 12:30 sharp. Okay, you'll get it from there. The lecture, you can go through the video lecture and get your preparation according to that. And if you have any question, you can discuss with me as you know all this system. And today, during the class time, all very important thing I told you earlier, I'm telling you again today, reminding you as well, you all guys should be very be attentive so that you can answer to the question to get the bonus mark. Very, very important for you, remember. And class test is not so easy like what you are thinking or what you thought. Maybe you get 0 out of 20 in the class test, and in the final quiz you get very low marks maybe. If that is the case, then these bonus marks will help you to pull up. Some of the students got 25 out of 25 by the help of this as bonus marks last semester. So bonus mark plays a very important role to increase your marks. And very, very important, I'm telling you again and again and again, I'm telling you, all what you have to do, attend the class. If you do not attend the class, how do you get bonus marks? Sleeping at home. Careful about it. So each and everybody must try to come every day, attend the class, and achieve the bonus marks. And this is some sort of class test you can imagine. So anybody got any problem, anybody, you just let me know. But I'm just suggesting you, we are not giving you attendance marks, but indirectly this bonus marks is your more than the attendance marks, if you understand. Okay, now let us come back to the point. Today actually we have another 3 minutes in hand. If any other things we need to discuss, we can discuss. For the lab of this course, actually you know that the lab teacher will be giving you the instruction, and this time Abir and Imtiaz will be conducting the lab, so mostly on the MATLAB Simulink, and then some sort of video demonstration can be shown to you with the servo system at the end. If the university open, then physically you can do the experiment, otherwise some sort of virtual experiment you have to go. And Imtiaz and Abir will be telling you in the lab class. So I have uploaded some of the experiments using the servo system on the BUX. I hope that if you can download those things and the manual is given of the servo system, then it will helpful for you to understand those things in advance as well. Okay, that's what can go ahead with the lab session. And yep, there will be what do you call it, another class test after this, and then before the midterm 2 class tests I'll be taking, and all are normal class tests, no instant class test or anything like that will be happening here. So all of you, I hope that aware of it, but I'm just telling you before we start, if anybody got any question from the last lecture, what we have gone through. If anybody got any question, can ask me. Otherwise, we'll jump to today's lecture. Okay. Just one thing I'm asking, can you see the screen? It's written discussion from the previous lecture. Can you see the screen today?
Yes, sir.
Okay, if I put this thing, okay, now can you see, or you feel you will see the blank screen? Are you seeing the same thing?
Yes.
Okay, good. Thank you very much. Then it's all right. Now, let's come back to the point. I'm asking you again because we have last 1 minute. If you don't have any question, then you can go ahead for today's class. Actually, today we are going to talk about the block diagram reduction technique. The block diagram reduction technique, there will be 2 class on this block diagram reduction technique. And you already last class, you saw the block diagram reduction for the you know, the superposition theorem you applied for the meso system and a CISO system. You can just simplify the canonical form. That is what actually today's topic, and then next class we'll see the another method, which is the professional method in control system engineering era. So the control system engineers used to use the second method in their critical life for any critical system. But if the system is very straightforward, then they use the block diagram reduction technique. Okay, so we are going to the block diagram reduction technique class. Okay, can you, okay, you just check first whether you can hear the sound. If you cannot hear the sound, you have to tell me, please. Okay. Okay, now can you see the screen? Oh, I'm sorry. No, hang on. Okay. Okay. Can you see the screen?
Yes.
Yes. Okay, good. Now see the, hear the sound. Sound is clear or not? Just 7:30. 30. We can go and start our class now. Now let us have a look of these things. Okay. Is the sound clear to you all?
Yes, sir.
Okay, go. I'm telling you, I'm with you. If you have any question, anybody, you please raise your hand wherever you have any question. And when I ask question for bonus point, I'll announce beforehand. And if you can answer within time, you raise your hand. And all of you, I assume by this time familiar to send me the solution. How? By getting the snapshot and send it to me through the chat box, or cannot, worst case scenario, you can send it to me by email. Or if you can show your screen online, that also can be acceptable. That means I'll give you the screen share and you can share your screen and you can show me how you can get the snapshot. And on your screen, if you can bring it, then I'll give you the screen share option, and then you can share the screen to everybody or to me. Then I can check your answer is correct or not. This method each and everybody should learn by this time, because you are in the second semester, online semester. By this time you should know that. I assume those who know that, those who know how to do that, they are one step ahead to challenge the bonus marks. So I hope that most of you already done it, already know it. I hope that. And you still don't know, please learn this thing by yourself. This is very straightforward and very simple. All what you have to do, get the snapshot, what you work for the bonus marks, what you've done, you get the snapshot and put it on your screen. Somehow you have to bring it on your screen, and I'll give you the screen share. You can show me. Is the easiest way. This is everybody should learn. Everybody should know. Now it's up to you how you do. Okay, now let's come back to the point. Or through the chat box, you can say. Two options are there. Immediately you can do it and get your marks. All right, let's go and start. All of you try to note it down, even though it is very hard for you to do. But today we don't need any calculator, but at least the paper and pen is required. So at least you take your class note and your pen, and you have to solve the problem with me. Otherwise, you can never do it again, and you cannot understand as well. So all of you, please try to follow me. Okay, the thing what I going to start today with the block diagram reduction technique. As I just discussed about it, the requirement of the block diagram reduction technique. Why? Because if our target is to do what? Our target is to do mathematical modeling of physical system. That is what our target. We have to develop the mathematical model of physical system. Physical system means, this is very important. If I say the model, okay, you go for develop the aircraft model. What does it mean? It means if you go to the architecture department, they will, you know, with their machine, they will develop a model of aircraft. That means that physical model they are going to give us. But as an electrical engineer, the model means not that architecture model of an aircraft. It is a mathematical model which represents the aircraft. It is the engineering job. Otherwise, you are a diploma engineer. If mathematics is not there, you understand. So this is very, very important course, and this is a very important topic as well. So our target to define any physical system, either it is an aircraft, or it's a car, or whatever you are going to go for, any system, if you want, dynamic system, you want to develop, you want to represent, you have to represent it mathematically. That is engineering job. That is a graduate engineer's work, not diploma. Otherwise, you are diploma. Okay, so this mathematical model we are going to develop after learning these basic things. So in order to develop the mathematical model, or which is nothing but mathematical model is nothing but the what? But the transfer function of the system, which you have seen already last class. Okay, so mathematical model, if you want to develop from a physical system, then through the signal and system, you have to develop the block diagram. That one I'll show you how to do. We are going to take a physical system in our course, and our physical system will be what? Our physical system will be servo motor. The servo system we can call servo system. The whole servo system will be our physical dynamic system. That servo system, what I'll talk about it later. The servo systems mathematical model we are going to develop in our course. That is, we are going to find the transfer function for the whole servo system, step by step. So when first thing is servo system, through the signal and system, we are going to develop the block diagram, and after the block diagram, then we are going to reduce the block diagram. That is the block diagram reduction technique. We are going to reduce the block diagram, and after reducing the block diagram, then we are going to find the transfer function of the servo system. That is what step by step we are going to see in our course, and that will be our first topic of the syllabus, mathematical modeling development for physical system. You have to go for a lot, because the servo system is a what system? Is it electrical system, it's a mechanical system, or say a chemical system, sort of things. Servo system combination, it's an electromechanical system. So it is required electrical as well as mechanical plus mechanical. So electrical and mechanical, these two systems combine together the servo systems. So we need to know about electrical system analysis and we need to know about mechanical system analysis. These two systems combining together, these two knowledge combining together, giving us the idea about servo system. And then we can go for step by step to through the signal systems. We have to develop the block diagram reduction technique, give us the transfer function. So all these things we need to learn. So what are the things we need to learn? First, for that we need to learn the block diagram reduction technique. Then we need to learn the electrical system. Then we need to learn the mechanical system. You are thinking, what is this electrical system? We know mechanical system, we may not know, but we need to know. Yeah, each of the elements, how to find the transfer function for electrical system, how to find transfer function and block diagram, how to develop the block diagram for this system. These are the things we are going to learn. You will see as a new thing for you for the mechanical system and so on. In frequency domain, we are going to find it. After learning these three items, and under mechanical system, translational and rotational, both case we are going to learn, and then combine together, we are going to get the transfer function for the servo motor. That is our ultimate target for this chapter. So step by step, we have to go. This chapter is a bit long chapter because it is giving the complete scenario in your future, in your practical life. If the assignment given to you that you get a job in BA system or in a car company or something, they're asking you, okay, fine, you develop the mathematical model of this system. Now, how you do it? That is what we are going to learn from this chapter. So this chapter is very important for you. So all of you understand why I am going to start with the block diagram reduction technique, because this is the first thing we need to understand in order to get the, I'm sorry, because this thing is, okay. Now, this is the first thing we need to, so machine is hang. Minute. Okay, now, okay, it's gone. Just let's jump to the, then our main thing, that is your mathematical modeling. I'm sorry, the block diagram reduction technique. We are going to learn first, and after finishing this thing, then we will jump to the electrical system, mechanical system. I think we can do it in the third class because it's a long thing to understand here. So we need to quite a long time to complete this course. So complete these chapters. Let's say the block diagram reduction technique, which is very much urgent. And the first thing we need to know that. So the block diagram reduction technique, if we start with first thing we need to understand that you look at it here. This is, I said, techniques. That means there are more than one technique to reduce the block diagram. We are going to learn the technique. There are two techniques to reduce the block diagram. And among the two techniques, one is, and this is all what you need to know as a control engineer. So this first one is known as a canonical form reduction technique. Canonical form reduction technique. Okay, reduction technique. Another one is your Mason's gain formula. Mason's gain formula using signal flow graph, or we call it SFG, signal flow graph. So these are the two techniques actually we are going to learn under the block diagram reduction technique. And today we are going to talk about the canonical form reduction technique. And next class, we will go for the other one, the Mason's gain formula. we'll learn this in the next class. And after that class, then we are going to start the electrical system, then mechanical system. After that class, we are going to develop the mathematical model of physical system for the servo system we are starting. So a couple of classes are required for this topic, and this is the very important topic, the basic for the classical control. So everybody should try to attend all the classes. Okay. Now let's come back to the point. Today, canonical form reduction technique, as I said, we are going to talk today. This is the block diagram reduction technique, which we have already seen in the last class, flavor we got, that the block diagram should be reduced. In this technique, the block diagram is reduced to canonical form. Canonical form. Okay, the block diagram is reduced to canonical form, and then find the transfer function which is coming through the C by R, and you can easily find it. So that is what the canonical form reduction technique tells us. Now, under the canonical form reduction technique, there are some basic laws. We can just see in short the basic law. The basic laws are, all of you just note it down, the basic law. You already know that some first law we can say that let's say if everybody can understand this thing very easily, that this is, let's say, G1, this is G2, two amplifier are connected in series, and if this is R and this is C, okay, and then what will be the equivalent? If I ask, everybody know that the equivalent will be what? Equivalent will be nothing but in the box it will be C, okay, C R. Hey, what is the thing will be inside the box? Can you tell me?
So G1, G2?
Right. It will be simply G1 into G2. That is the two amplifier gain will be multiplied together. So one amplifier gain is 2, another amplifier gain is 3. It will be 2 into 3, 6. That is very simple. You know that. And a second basic law is like this. If it is something like this, if it is in parallel, like this guy, okay, and it's coming like this, C and R, then this is G1, this is G2, and the equivalent will be what? If I say, then you tell me. If anyone can voluntarily tell me, no problem, can go ahead. C and R. What will be this one?
Sir, G1 plus G2.
Right, it is G1 plus G2 because it is in parallel. So it is, if we assume this is plus plus, definitely plus plus, and then it will be G1 plus G2. Anybody got question? You please let me know, because you already know about these things. So it is not a big problem for you to understand. And here we go. Another thing, we can know that if this is not parallel, the previous one is a parallel, but if this is the feedback there, and then also you know that this one G, this one H, this one G, and this is H, the C, this is R, this plus, and this is negative feedback, for example, if I say. And now it is G, remember, it is G, and this is H. Then you all know what will be this, right? What will be this? C and R. You should know that. Anyone?
So GH.
Sir, R plus minus
No. No.
1 plus GH.
Right. Last class, you look at the canonical form. We have derived G over 1 plus GH. Look at it. Isn't it? The canonical form. If this is, you okay? All of you?
Yes, sir.
Yes.
Okay, good. So this is in series, in cascade or series. This is in parallel, and this is with feedback. These three basic law we can have, and you already know. Now I am going to show you some special case, some special case number 4, law number 4. If you go, law number 4 said that law number 4, you should go for number 4, is moving a summing device, moving a summing device, moving a summing device after and before, after or before before a block. Before a block. Okay. If it is the thing, then how it is happened, we can look at it. This is number 4. And number 4, you can go for number A first. There are two things we can see here. One is like this. All of you note it down, because you have to use this law in order to apply the method. So this is what, if you go, another law, it's a C and R. This is, let's say, plus, and this is plus minus, and this is R, and this is, let's say, X, and this is your G block. So before the block, that means if you want to move it after the block, the summing device, you want to move after the block, then the thing is becoming like this. This is G is coming here, and the block is coming afterward, and then your C is coming here. Okay, and this is your plus, and this is going to be your the other block, which is going to be simply the G. So it is going to be your R, this is X, and there is C. So what is happened here? Okay, what happened here? Plus minus this thing. Oh, we are going to, oh, hello, can you see the screen? Hi, what happened?
Yes, sir.
Now listen, yeah, I'm just telling you one thing. Zoom is going to cut off. This is block. And if we do that, you see the summing device gone there. On the left hand side, the G is coming and X input coming there. So what happened? The C is remaining same here. If you go, it is the equivalent, no change. The reason the output is same. Look at it. Hey, can you tell me what is the thing here? What is the thing here? This one will be what? R? Anybody can tell? R plus minus? Okay, I'm talking to the floor, the live class. Can anybody raise your hand who can answer voluntarily? Okay, Riful Sheikh. Okay, Riful, you can go ahead. What will be the thing here? R minus what?
Sir,
You have
R
to
plus
complete the
minus
whole
X.
answer. You have to complete the whole answer, A, B. Then only you get 1 bonus point, remember. Okay, go ahead.
Sir, it's R plus minus X.
Okay, wait
There.
and see. Hey, Doc.
Sir, X.
R plus minus X. So if this is R plus minus X, it will be, C will be what? Now, Riful, what will be C? Hey, Riful, can you live class Riful? Riful check?
Sir.
Yeah. C equal to what?
G into R plus, G into bracket R plus minus X.
Good. Just wait and see. G into R plus minus
R
X.
plus minus X.
X. That is the equation for the output. C equal to this. And if you go to the right hand side, I said left hand side and right hand side are equivalent. If it is equivalent means, what does it mean? The output equation should be same for both cases. That's it. And if you go here, this is what? This is G into R, right? And what is this one? This one is what? Yes, Riful, go ahead, Riful check.
Sir, GX.
G into? Anybody?
X.
G into what?
X, sir.
Excellent. So G into X, that is GR. So what will be the output here in that case? Output will be what? Output will be the summation of these two things. Yeah, Riful check, C equal to what?
Sir, there's GR plus minus GX.
Things GR plus minus GX. Plus what GX. That is what your C. So your C is becoming here. C is going to become here GR plus minus GX. So what does it mean? If you take out G, you get R minus plus minus X. This is your C equal to, right? Hey, you understand it? So you see,
Yes, sir.
yeah, in both cases, the C is same. Okay, Riful.
Yes, sir.
This is for A answer. You have to wait for 4B, and if you can answer fully, then only you get 1 bonus point. Wait and look carefully.
Okay, sir.
The C is same for both cases. What does it mean? It means these two sets of blocks are equivalent, isn't it? So you can move the summing device from before the block. If you want to move it after the block, you can move the summing device after the block. But the left hand side here and here, the changes are both are having a G with each of them. So this is what one of the one of the law of block diagram. So I hope that everybody understood. Yes, sir. Hey, we have 3 minutes to go.
Sir, but at the left there is one. How is it? How these two are becoming equivalent?
No, this is the equivalency actually, because when you move the summing device after the block, then this block is split into two, and it is coming. One block is coming here, and this block is coming here. This block is coming here. When it goes there, then this block jumping into this two, and it is giving you the equivalence of this thing. You understand? These two are,
yes, sir.
Yeah, that's why I can say that if I want to move the summing block on the right side of the block, then the block will be divided into two blocks and coming to the input of R and X. This is the law. And the validation, how can you validate the law? By finding the output equation, C equal to. So in the first case, C equal to this. In the second case, C equal to this, which are same, right?
Yes, sir.
That's why these two blocks equivalent are valid. So you close your eye and you can apply. You have in the block diagram, you have the block like that. You can replace it. You can replace it in this way. You understand? It can be replaced in that way. Like in EEE 201, use source conversion, voltage source to current source conversion, a delta Y conversion. Remember?
Yes, sir.
Yes, sir. Like that. Let's say this is current. So this is current source. This is voltage source. So current source to voltage source in the circuit you're required to modify, replace it. Then you do it like that. This block can be replaced by that block. Try to get my point.
Yes, sir.
Good. Now I'm going to delete it. I hope that every duck understood. Okay, it's taking time. Be the common sense. And if you do not come, I have nothing to tell you, remember. Okay. I know some of your internet connection. Let them come on mission that it will be after the thing, so it will be moving on the left hand side. So C is coming there, R is there, this is G, and this is your plus minus X. Plus minus X is here, and this is plus. Okay, so this is going to be your equivalent circuit. This is moving to the left. So what will be the thing coming there? The summing device is moving to the left, and then it is coming over here, and G is going to the right. Here, see? So G is going there directly, but the question is in the X coming here with a difference, which is this 1 divided by G. Okay, this is the thing. Okay, I'm just going to draw it because it's important. I'm going to draw it like this, 1 divided by G. So you can all understand this is X, this is R. This is R. So this is a plus minus sign, this is a plus sign. So this is what is going to be the second law. Law B is there like that. So I think you can understand it, how this can be done. Now, in this case, what happened? The summing device is moving before the block G. If it is moving before the block G, then G on the outside is coming like that, and this is coming like this. So if you go in that way, then we can see, yep, it is valid because of this part. What is this part here? It will be RG or GR, and what is here is X. X, so it will be what? Over here, it will be straight away the summation of these two things, GR. Yes, Shiful, can tell me the answer.
Sir, there, sir, it will be GR plus minus X, sir. GR plus
And
minus
X. So you are getting here X plus GR. Oh, sorry, X, yeah, GR plus X plus minus X. That will be much more better. Okay, so I'm writing here GR plus minus X. You are getting here like this. That means your C is nothing but GR plus minus X. This is what the output equation for this case. Now, if you go here, then it will be what? It is giving you R, and but here, what is that? Hey, what is this here? Yeah, Shiful, go ahead, Riful.
Sir, there will be, sir, X into 1 by G. It means, sir, X by G.
If you go, it will be what? It will be X over G, right? And what will be here? Yeah, what will be here then? It will. Yes, Riful, now.
Sir, it will be R plus minus X by G.
Be what? R plus minus X over G. This is the equation at this point. Okay, R plus minus X over G. And what will be C then? Over here, it will be just multiply with G. Yeah, Riful, go ahead.
Sir, it's just multiply with G, sir. G into R plus minus X by G.
Good. G. So it will be G. Okay, sorry. It will be G. What is that? G into R plus minus X by G. That is what this thing, which is nothing but your C. So your C equal to this. That means C equal to this. You are getting. Now, what is this equal to? If you multiply, what if? Okay, Shiful, what is the final answer?
Sir, here, sir, GR plus X, sir. Plus minus X, sir.
Get GR plus minus.
GR plus G.
Plus minus what? X.
GX.
GG cancel. Okay, GG cancel. So X. This is what your C equation. So your C equation here, C equal to this, and C equation here is same. Exactly the same way. We can see that yeah, both blocks are giving the same equation. So it is, we can say it is valid that yep, both are equivalent. So what can we do? If in the block diagram, complex block diagram, if we see something like this and we need to move a summing device before a block, then we can simply replace it by this one, or vice versa. If this one is having, we can convert it into that one, like a voltage source to current source to voltage source. We can, because these are equivalent. Hey, dumps, understand, law 5 is going to tell us that moving a junction point here. So all of you just note it down that it is a movement of a junction point. So moving a junction point, I don't need to explain this thing. I think you can easily understand how to validate it. Moving a junction point, same way, there are two things. One is A, and A is something like this. If the block is here and the junction point is here, if the junction point is taken off from here as a X, and this is C, and this is your R, which is going in. So this is G. So if you want to put the junction point on the right side, if you want to move it on the right side of the G, then what will be the thing coming there? It will be G here coming, and the point is going there. The junction point is moved here, and it is coming here with 1 by G. 1 over G. So this is what the X you are getting. This is what the G you're getting, and this is your R, and so on. So this is what you need to note, but I'm not going to show you here the validity of these things, because how to find the validity of it, I have already shown you in the previous law. So it's exactly the same way you can test it by yourself. Yes, the output equation is same for both cases. Now copy the next one. If the junction point is before, if you want to move it before the block, that means the junction point is locating after the block, but you have to shift it before the block. Then what to do? That means it is after the block, the junction is here, but you want to shift it before. Then how to do it? Then you have to do like this. Just the G you can draw, see here, and the junction point you brought it here. So in this case, it is simply a G coming there, and you have your X here. It's a CMOS system, single input, two output. Like that way, if you do the analysis, you can find it. Okay, so this is the way you can find the the equivalence of these two. Now, you can find the equation for C and X, and you can find the C equation X, and then you can see both cases are same. All right, so should be fine. I think if you cannot understand, you can discuss, but for the timing, you note it down. What can we say here? We can say here that if we want to move the junction point, we want to move the junction point here. We want to move the junction point here, then what to do? In this case, if you want to move the junction point before the thing, I think before the block. If you want to move the junction point, sorry, see. Okay, if you want to move the junction point before the thing, then what to do? That means this one you want to move here. Then what to do? These are the two law for moving the junction point before the block, after the block. Should be fine. All of you okay? Example first. Example 1, if we go like this, example 1, all of you can just look for this. This is very much. Anybody got any problem like that? Immediately tell me. Everybody is having the same problem, remember. Okay. unless your own problem. Okay, now G1, G2. Okay, so the question, you just draw the diagram, then you can start solving this thing. Okay, plus, plus, and this is what the final C. Okay, and then you go back. Okay, you go back to this. Okay. And here is another summing device, and you go back here. So this one is negative, this is positive, this positive, positive, G1, G2, this is G3, this is G4, G4. Okay, and this is the way the arrow marks should be. This is the way. So this is also plus, and this is minus. Okay, now what you have to do is you have to find the one block here where output is C. Oh, that means C by R. C by R equal to what? You have to simplify the block. Simplify the block into this and find what is this got. All of you, bit faster. It is an open question to you all. If you can do it, you get 0.5 bonus point. Anyone? If you can solve the problem, raise your hand and show me in the chat box or sharing a screen. Worst case scenario, the email. Go first. Anybody can complete it? Raise your hand. Habibur Rahman. Yeah, Habibur Rahman, you raise your hand. How you want to show me? Screenshot or chat box? Habibur Rahman, open your microphone and tell me how you want to show me the answer. Sir, screenshot. Okay, I'm sharing the screen with you then, and you just go ahead. Okay, just a minute. Okay.
So I can send mail.
No, you can show me on your screen, no problem. Can you share the screen? On your screen, you can just share it, and we can see it. I have given the sharing screen permission to you. Just share. Yeah, good. Excellent.
Sir,
that's a good thing.
Can you see?
You can see your Zoom. Okay, go to that screen where your picture, you upload it. Can you see the solution on the computer screen, in your own computer screen? Can you see?
No, sir.
Oh, then how come you show us? You have to see first on your screen and then you can show us. Yes, oh, sir. This is a camera. Okay. Just 1 minute in video. Okay. Now, I think in that situation, can all of you see? Hey, rest of you?
Yes, sir.
Okay, good. Now, this is directly you have written the answer, Habib Rahman, but yes, you have to simplify the block. Maybe the two block, the 4 block there. So 2, yes, 2, you have to simplify first, and then you apply the canonical form and get the answer. But anyway, what can you show me again, please? Because your camera is not clear. Okay, G1 plus G2 on the top, good. And it is G3 minus G4. And you written, why you written, everything is fine, but why you written 1 plus minus? Can you tell me why you written 1 plus minus?
No, sir, I cutted the minus sign.
What will be the answer, exact answer?
Sir, G1 plus G2 divided by 1 plus G1, G1 plus G2 into G3 minus G4.
Okay, good. It is plus because negative yes, feedback. Good.
Yes, sir.
Thank you, but you cut the video. I mean, you, yeah, close it. Okay, good. Thank you. Just a minute. Okay. Now, okay. Now, let us go. Your answer is correct, Habibur Rahman, but steps should be taken in this way. But you did very fast. That's why you got the answer directly. But I hope that you understand how to. If anybody got the answer, just tell me. And you understand this, and then it is becoming a canonical form. That's what the canonical form first you have to develop. You simplify it into canonical form, and after that C by R you can find it. And then this one will be, the whole thing will be G, right? The whole thing will be G, and this whole thing will be H, and then you can easily find the canonical for C by R equal to what? Go and tell me.
minus G.
Right, G3 minus G4.
G2.
Right, that's it. Now you canonical form. Canonical C by R equal to what? And simplify and tell me the answer. That's it. What is the answer? Anybody got?
Sir, the answer is
Yep.
yes, sir.
On the top,
G1 plus G2
G1 plus G2. Good. Then
over 1 plus
1 plus what? Hello. Anyone else can come up with the answer? 2 into G3 minus G4.
G1 into G4 plus
G3, G2, G3. It's okay. Go for it, because I'm not asking you to go for polynomial form or something like that. You can keep it up to this also. And if you simplify, you can multiply. You want to on the top microphone problem. Okay. Anybody else? Okay. Okay.
3 minus
you can keep it up to this also.
Yes, sir.
Okay. Good. Okay. Now I think everybody can clearly see this. Okay. Now this is the problem 1. It's very simple, as everybody saw that. Habibur Rahman, you are correct, and you'll get 0.5 bonus marks. Thank you. Thank you, sir. Now, all of you jump to example 2. If you go with the example 2, then copy the question first, example 2, and then we'll solve the problem. All of you be ready to copy the question a bit faster. G1, then we have a summing device here. Then we have another summing device here. Then we have another summing device, 3 summing device here. And then we have a G2 block here. And then you are getting C. And this block is G2. This block is G3. And if you go with this, and you can get a feedback of H1. H1 is coming here like this. And then another one you are getting here as a H2. H2 is coming here. And then another one. So we're getting H3. And H3 is coming here. Okay. Now you can see that this is a positive feedback. This is negative feedback. This is positive feedback. And this is negative feedback. And here it's signal flowing, all are positive. So this is positive, this is positive, this is also positive. So you can see now the block diagram like this. If this is the block diagram, all what you have to do is ultimately you have to find the same thing. C by R equal to what? That is C by R. Ultimately, what is this? The final transfer function. That's what you have to find. So go for it first. Okay, let us go and find the solution to this problem. I'm talking to the live class. If you can solve the problem correctly, you will get 1 bonus marks. Raise your hand once you complete. Okay, once you complete, raise your hand. Okay, I see two participants raise their hand. One is Habibur Rahman, another Anamul Hassan Tanvir. Yeah, Anamul Hassan Tanvir. I'm sorry. Anamul Hassan Tanvir, can you?
Yes, sir.
Yeah, I want to see your solution. How you want to show me?
Sir, I will send you the picture in the chat box, sir. Give
Good,
me.
excellent, no problem. Go ahead, bit faster. Once you've done it, let me know. Okay, there is another guy, Riful Sheikh also completed. Okay, let's see. Okay, a bit faster. Okay, then Fardin Anwar also done it. I didn't get in the chat box yet. Have you sent it? Anamol, have you sent it to the chat box? Not yet. If you can't, then you can show me on the screen of your computer, get a snapshot. Or like the camera just now, someone had shown me, Habib Rahman. Are you getting trouble to send me in the chat box? Hey. Oh, he left. What is this? Okay. No, he did not send me yet. Okay, I think he may send it to me by email. Okay. No, not in the email also. Okay. So I think he already left the room. I don't know what's wrong. Okay. Now let's come back to the next person, Habibur Rahman. Habibur Rahman. Hello, Habib.
Yes, sir.
Yeah, what is the answer you got?
Sir, G2, G1, G2, G3 divided by 1 plus G2.
Okay, I'm just asking you the answer. Can you write it into the chat box?
So, okay, sir, I'm writing.
Let's see who can send it to me by chat box. It's faster. Did you show? I'm very much wondered because Nassim should tell me that, sir, yes, I can't or cannot. He simply left the room. Okay, if cannot send it by chat box, you should send it by email. Worst case scenario, I said. You did not learn how to do it. Okay, now listen. What is the answer? Have you sent it? You also don't know how to send it by chat box, right?
Sir, I say.
Okay, I got it. Yeah. Okay, this is what you got the answer. G1, G2, G3 divided by 1 plus G2, G3, and G4. Okay, this is what, no, you cannot change it now because you have given the answer like this. So we assume your answer is G1, G2, G3 divided by 1 plus G2, G3, H1. Absolutely, this is not correct answer. You are out of the competition. Now let's come to the next one. Riful Shak, you are the next guy. Can you write the equation? Can you see the equation he had written? Riful?
Yes, sir.
Okay,
Yes, sir.
you send me your answer in that way. Faster. Okay, this is yours. G1, G2, G3 divided by G1, G2, G3 divided by 1 plus G2, G3, H1 minus H2 plus H3. Okay, good. I think this is the correct answer. Now, I'm asking Habib, Riful Sheikh, how can you show me this?
Sir, by screen share, sir.
Excellent. Go. I'm going to show you give you the screen share option. Okay, I have given the option. Now you can go ahead. Anamol, you dumb. What happened?
My electricity was gone, sir.
Oh, I'm sorry. I'm so sorry. I'm sorry. I have a emergency contact number in your hand, right? You have
Yes,
to
sir.
pay
I
money
have
for
that.
I know you have to pay money for calling me. At least you could send a SMS. Okay, now let's come back to the point. Riful.
Sir, I mailed you.
Okay.
Mailed you the
I
answer.
didn't get the mail yet, actually. Okay. Okay, make it bigger. Make it like this. Okay, this one is you want keep it like this. Zoom out some more. Zoom out, make it small. That's okay. This keep it like that. Good. Hey, everybody can see. Everybody can see the script. Hello. You can see.
Yes, sir.
Yes, sir.
Good. Good. Excellent. Okay. G1 into G2 and G1 H1 minus H2 plus G2. That is why you have done it, right? You put it minus. Okay, and what is the in the second diagram? There is one summing device. Rifle check.
Yes, sir.
In the second diagram, second step. I mean, the second diagram it got a summing device. What is the feedback? Is there a negative feedback or positive feedback?
Sir, it's negative feedback.
I'm sorry?
Sir, negative feedback, sir.
Negative feedback. Good. Excellent. Then it's all right. 1 plus and this is okay. Okay. Thank you, Riful Sheikh. You can cut. You are absolutely correct. Okay. Cut it. Hey, come on. What is this? Yeah. Okay. Now let's come back to the point. Riful Sheikh got a bonus point. This is another one bonus point Riful Sheikh got. Now let us see how it is happened. It is a very important. Okay, now you can you do it? Hey, all of you in line with me?
Yes, sir.
Okay, go ahead. Now you try yourself and then I'll check. I'll give you a numerical form of this thing because these two are in series. So these things will be coming what? As G1 into G2, right? G1 into G2 and then this is a canonical form. You can see this is a canonical form. And the canonical form, yeah. So you can say that this will be reduced to G1, G2, I'm sorry, G2, G3 divided by 1 plus G2, G3. You can say the whole thing into one block, the whole thing. And then you can delete the thing inside. I'm just talking about the next step. Most of you will do it like this. And what you do next step is you have to write like this. One box you have to draw. Look at it. Don't do it. Just look at it. This is not the shortest way. This is the longest way. So this method try to avoid for this special problem. This thing 1 plus G2, G3. This is the normal process everybody should follow, isn't it? Hey, listen what I'm talking. Is it? Yeah, go. That's why I'm showing you. Again, if this whole thing is your G, try to understand what I'm talking. You don't do it, please. Listen. This is G and this is your H, the blue one. Okay, then the blue got the whole blue circle, the blue canonical form you can see now. This whole blue canonical form, this is G and this is H. So you can easily write it another canonical form with the blue one. With the blue one, you can write another canonical form. Another canonical form will be what? G over 1 plus or minus?
1 minus.
Right.
Minus.
Good. 1 minus GH. So you can go for 1 minus GH. Like that way, you have to do a big thing because you have to substitute the value of G here, here, and H here. And after that, you have to simplify it. You get another big block. Like this way, if you go, it kills a lot of time and it requires a lot of time too. I hope that everybody understood. But this is not the way to do the job. The job needs to be done. How? I'm going to show you is the shortest way to do. Okay, now look at it. taking it off so that you can get it faster. This is, I'm going back to the original diagram in order to solve the different way. Okay, now, okay, so look at it. The way you are going to do is, these are the summing device, 3 summing device, and here in between the summing device there is no block. All are 3 summing device together. So what you can do, you can combine them together into one summing device. So if you combine them into one summing device, then the summing device will be like this. Look at it. One summing device, one is coming from H1, one is coming from another one is coming from 3 input. So this is your plus, and this is your going to the G. But this is minus, this is plus, this is minus. Do you get it? Oh, the plus minus didn't come yet. What happened? Oh, I'm sorry. Just a minute. Just a minute. Again, making trouble. What is this? Problem coming here. I'm talking about these 3. All these 3 signals. Actually, if you want to combine them together before that, one thing you have to do, this is a negative, this is positive, this is negative. There are 3 different, this 2 different type of sign. You have to convert into one type of sign. Let's say all are negative, then what to do? If we want to make all negative, then we have to look into this positive sign. What we can do, we can bring this positive, this negative sign, this positive sign, you want to make it negative, you can make negative here and put the negative before the H2. Before the H2, you can put negative and you can put there negative. In that case, you can remove the positive sign from here. You got my point?
Yes, sir.
So that negative as a positive, like last class I show you something like this. So in that situation, all are negative, all are negative, I'm sorry, all are becoming negative, and negative. All are negative. So you can combine them, one negative. And these 3, these 3, H1, H2, H3, you can combine them together as because all are in parallel. Because this is coming in this direction, this is coming in this direction, it is coming in this direction. All are parallel. Since all are parallel, so you can write here, this is H1 minus H2, a summation. If G1, G2, G3 are in parallel, then you have to add them. As you told me, G1 plus G2. Rule number 2, if you see, that you can apply rule number 2 here, and then you can write it like this. H1 minus H2 plus H3. So you can, if you have any question, please tell me. If you can now delete the whole thing here and put only one line over here, and that will be just this gut. One thing here, from here you can just put only one box there where you can write this thing as H1 minus H2 plus H3. If you write it, then all the things can go, all the thing can go, all the things can be deleted. Okay. Now only thing you got is you can just straight away connect it here with one negative. All the negative sign will become one negative sign. And this thing can be written in the very straightforward. You can get the result now. Oh, I'm sorry, this is R. The canonical form we have introduced, and now you can easily find what is the final answer. I think by this time you got the answer. What is the answer you got? What is this? We should jumping to this. Okay, now can you tell me again, please? G1,
G2, G3.
G3 divided by
1 plus G2, G3.
G2, G3 into
H1 minus H2 plus H2.
Plus H3. Yep. Okay, that's good. Excellent. So C by R, you are getting like this. This is the final answer to this problem we can see. I think you can understand it. Now let's go to another new whiteboard and another problem we are going to do, and that's the end. I think we can finish, and then you can give one example, and the practice problem you can solve by yourself. Can you please note it down a bit faster? The example, what is the example number? This thing's 3, right? Okay.
Yes, sir.
Yeah,
Yes,
just
sir.
go and copy it first. Okay, this is the one, G1, and this is another summing device. Then you go to the next G. Then you go another thing, and then you go to the summing device here. This is C. And summing device here. Okay, now if you go with this, then from here onward, you can take the things back to this, and this one is coming another one from here to this. Okay, that's done. And now you can just go for, this is your R, this is your C, and you can write this is G1, G1, this is G2, G2, this is G3, this is H2, H1, this is H1, this is H1. Can see H1, yep. This is H2, H2, and this is H3. Yep, this is the way you can go. This is okay, this is okay, it's okay. Okay, now we go for it plus. This is minus, this is minus, this is plus. This is what you go for, is plus. And then there is another one here. You have to add these things as a unit feedback coming here, which is also plus. This is also plus. This is minus. Okay, so this is G1. I think all are given. Okay, now this is the problem. You have to find the solution. Yeah, I don't know why it is cutting, solving the problem. But you need to, and try to solve it faster. And how you go and do it, think about it. Okay, to the real life class, it's a challenge for you. If anybody can solve the problem faster, he'll get 1 full bonus point. You have to show the steps. So do it on the white paper and find the answer. Go ahead faster. Hit this. I'm sorry. Okay, anyone could solve the problem? No one? Okay, I think maybe you cannot solve it. Look at it. Where is the problem that you cannot? And hopefully after this you will be able to solve it. Let's go and see. Okay. Hello.
Yes, sir.
All of you, okay, online. Now just try to find the solution. A little bit hints. Is it 5 or 4? And let me know if you got some answer or something like that. Please. And let me. It is very short. If you move the point from here, the red line, if you follow, if you move the point from here to here, that means the junction point, if you move on the right of the block, okay, junction point on the right of the block, which law? Is it 5 or 4? Okay, it's an open question to the live class. You will get 0.5 marks bonus point. If anybody can answer this question, raise your hand. Which law should be applied to move
Law
this?
5.
I said raise your hand. Okay, now who is the guy? Wasi Iqbal. Wasi Iqbal, you tell me which laws, 4 or 5?
Sir, moving the junction 5.
5. 5 got A and B, right?
Yes, sir.
Which one, A or B?
1 over A, 1 over G. A, sir.
Oh, no, 5A or 5B?
5A, sir.
5A. The point should go from. Okay, Wasi Iqbal, you are correct. And let us see after that how to go.
5.
5. There are 2. One is A and B. 5A or 5B?
5A.
5A. All of you look. It is 5A. If you move this thing, if you move this, then follow the 5A. And if you follow the 5A, then what it should look like, you can just see. It look like this from here and just, okay. Yeah. Then, oh, sorry. After that, you can show in another slide. View all whiteboard. Okay, I'm going to show you here. Then you can see this. Okay, I'm going G2 by G2, 1 by G2, and this is the box here, and you can go for it like this. So your thing is coming like that way. So if you go to that slide in this way, if you go, then we can delete this thing and we can replace these things by 1 by G2 thing. So we can delete it from here and we can insert a box here. I'm talking about the box will be coming here, over here, and it will be joining with this together. I'm going to connect it from about the box is in this way, so that this box can be a little bit it can be like this. So sorry. Okay, and like this. That means this is, and then here is the box where you have to join here, plus minus and plus, and this guy will be what? This guy will be 1 plus 1 by G2. 1 by 1 plus G2. Oops. Okay, then you can solve the problem accordingly. 1 plus G2. 1 by 1 plus G2 will be inside the box. After that, I don't need to do anything. You can easily do it by yourself. You can combine this thing, right? You can, yeah, this one canonical form. Then this, you can Okay, I'm asking still, are there anyone could solve the problem? Nobody could done it yet. Okay, look at it. Form, this is another canonical form you can put, and then combine them together. Okay, after that you can develop a canonical form again with the big one, and then you can multiply the whole gut, and this is one canonical form, as I told you. This is one canonical. After that you can just normal canonical form reduction, you can apply the canonical form and then multiply, and you can easily find the answer. Only the critical point is here, shifting the junction point. Is it okay, you think, or you have some question? Tell me. You understand how to do now?
Yes.
Okay, all of you, can you please can you please get a snapshot from your mobile, this thing? I'm just going to out from here and check last moment that I can access to the show me or not. You get a snap of it, all of you, and then you try to solve the problem the way I told you, step by step. Okay, I think you have taken the snapshot. Okay, I'm going to next class within 15 minutes time. We can discuss about the problems or anything. Should be fine. Anybody got any other type of question? I cannot show you the whiteboard unless it is very much urgent. Do you have any question other than what I told? No. Okay, fine. So just keep it in your head that next class in the lecture 6, we are going to have CT1. And I hope that should be fine. And if any question, anything, we can discuss it in the next class past 15 minutes. Please note it down. Don't waste the time that 15 minutes. Thank you very much for your patience and attend the okay, all of you can just wait for a second. I'm going to show you. Okay, I hope that all of you can see this thing in the what do you call that, in the BUX. If you see the practice problem, then you just get down this practice problem from the BUX, and you can see I have uploaded already the practice problem like this. Actually, that's what I'm. Before that, I'd like to tell you one thing. Can you please write down the answer to the question of the unsolved problem? You will solve this problem because it is very straightforward to solve the problem. Hey, do you understand what I'm talking?
Yes, sir.
Yeah, please, all of you. I'm talking to the live student, live class. All of you, please write the answer to the question. Example number 3, what we have seen in the previous example. It says the answer will be like this. All of you copy and then try at home. And if you cannot get the answer, next class before 15 minutes, we can discuss it, no problem. But you try after solving the problem. The answer will come like this. So you can note it down, please. G2H2 plus G1H3 G1 G2 H1, okay, into 1 plus G3 H3. Okay, this will be the answer to the question. What question do you understand? What question? The last question. Yeah, the last question. I think you could not solve the problem, but the canonical form, I have shown you how to reduce the canonical form. After simplify, you will get this answer. I hope that all of you can solve this problem by yourself. Now let's come back to the point. This is the problem I have given in the box as a practice problem. All of you can solve this problem. If you look at this problem, what is this problem? This is a meso system, right? And meso system problem you have solved in last class. Single output, multiple input, single output. You have to apply what theorem? Can you remember, anybody? What theorem you should apply here? You are going to get y equal to what? Y equal to yx plus yd. Remember, I told you last class. Superposition theorem, right? So at a time, if you consider x, then d equal to 0. If you consider other way around, if you consider d then x equal to 0. That's the superposition theorem. Last class I show you, right?
Yes, sir.
And apply the superposition theorem and you find the yx and yd and then you add them. Exactly the same way you have to solve this problem. And if you go with the, for example, I'm going to show you here, a couple of things are given here. And if you go with this one, this problem, the second problem, then this one you have to solve it, and it's a very straightforward, very simple problem. You have to combine this together into one block and then combine the whole thing into one block and then the canonical form. You can get the answer very straightforward. I think every children should understand what I'm talking. Then you go for these problems. There are two problems here you have to solve next, this one. And it's the same thing, you have to solve the problem if you simplify first. And the same again is superposition theorem you apply here. There are two input meso system. And you can easily solve the problem here as well. These are the practice problem uploaded into the BUX, and you can try one by one. And all what you have to go for is, if any of the problem you cannot solve, please, please, please bring it in the next class before 15 minutes and we'll discuss it. If you cannot solve the problem in your during this time I'm asking for. Okay, this is one of the practice problem. Then another practice problem is coming here. There's a two practice problem. One is this one. I think you can see the thing. I'm sorry. Okay, this is another page what is given there. Okay, look at it. If you want to solve this problem, then you have to manipulate the block. Maybe the summing device, you have to bring it from this side. This summing device, this summing device, maybe you have to bring from that side to the left of the G1. And after that, you can find the solution to this problem. Very simple. Okay, then another problem over here underneath, actually you saw this one. Oh, the answer for the previous one, the answer of this problem is given here in the block. So you can easily find the solution by yourself. And then second problem, if you go with that, the second problem also same. You have to combine this together, this two summing device, to get the answer to this problem. Very simple. I think all of you can solve all this practice problem uploaded into the BUX. Hey, what happened? All of you sleeping? Understand what I'm telling?
Yes, sir.
Good. Yes, sir. Okay, I appreciate those who are still staying back up to this, up to the end of the class. Just stay back. I'm going to take a snapshot. Those who are present until the end of the class. Just don't move, please. I'm going to take a snapshot. After that, the class will be over. You can go. Please don't move. Okay, this is one. And another shot I'm going to take. Okay. All right. Good. Thank you very much. There are some dark already left the classroom. I want to check them. Who are the guys? Okay, and see how the performance in the cluster and other things. Okay, I'm very much thankful to you because you all stay from the beginning up to the end. During this time, you did not take the opportunity, the pandemic situation. VC said, no problem, you don't need attendance, and you took the opportunity. You didn't do it. You are serious, and I appreciate. Now, all of you can leave the classroom because our class is over. I'm asking Riful Sheikh, Habibur Rahman, and Wasi Iqbal to stay back to give them the marks, and rest of you, you can drop the class. Thank you very, very much for standing up to this. Thank you. And I told you already the class test, City 1 will be held next week, Sunday. So all of you start getting preparation, upload the video lecture so you can start getting your preparation. Thank you very much, everybody. You can go, only Riful, Habibur Rahman, and Wasi Iqbal can stay. Thank you very much. Now, Riful, Wasi, and Habib Rahman, can you see the screen?
Not yet, sir.
Okay, just I'm going to bring it 1 second. And then you can tell me where is your name. Okay. You are section 2 guys, okay. Section 2 guys. Okay, now you can tell me, all right, where is it? Okay, no, it's not the one. Okay, can you see now? Hey, can you see this?
Yes, sir.
Okay, now which number, serial number, you tell me. First of all, I'd like to ask Riful Sheikh.
20 maybe, number 20. Sir.
Number
Serial.
20, Riful Sheikh, this one, right? Okay,
Yes.
you already got this marks. So just what's equal, wait a bit. And you got 1 + 1, 2 marks today. Okay, good. Now next, Rahman, where is the number? Habib.
Sir, the screen is.
Serial number 1, 2, 3, 4.
Sir, I can't see the screen. It's very much small.
Oh, I'm sorry. Okay, I don't think so small. It's quite big. Okay, I can anybody help? Where is Habibur Rahman?
Habibur Rahman is in the last step, sir.
Last step.
If you go.
Is the last? Oh, here we go.
3-1.
33.
Yes, sir. 3-1 last.
Okay, 33. You got 0.5. 0.5. Habibur Rahman. And Wasi Iqbal, where is your serial number?
I think it's 19, sir.
19. Wasi Iqbal. You also got 0.5 today. Okay, Wasi, thank you very much. Thank you, everybody.
Sir, can I get a minute from you?
I'm sorry, go ahead. What is that?
Sir, in the example 3, sir, I tried a bit and I just found the last 3 blocks. I couldn't finish. Can you check, did I do in the right process?
You can show me, show me the screen. Bit faster because I have a meeting today in the department. So I can give you the sharing screen.
I will in the next class.
No, you can show me the screen bit faster. I have given the sharing screen. Oh. But for sure, no marks will be given. Can you share the screen? Hello?
Sir?
Okay, can we discuss it day after tomorrow in the first
yes,
class?
no problem, sir. Yes.
Okay, thank you very much. Thank you very much. Thank you. It's all right. Everything is fine. Okay, assalamu alaikum.